Hello and good evening, or good afternoon, as the case. I'm Sanhua Lee, a professor of phonology at Federal University of Minas Gerais. I'd like to welcome you to the talk by Professor David Odden from University of Washington in the Abralin ao Vivo series. Abralin ao Vivo is an initiative of the Brazilian Linguistics Association. Professor David Odden is a professor emeritus at Ohio University, and he is affiliate professor at the University of Washington. His research focuses on the area of phonology and language description, most notably features African tone and the description of Bantu languages. The title of Professor David's talk today is How much is in phonological UG? Before we start, I'd like to thank Professor David Odden for accepting Abralin's invitation, and to remind all of you that you can ask any questions and comments that you have in the chat. Please join me and welcome Professor David Odden.
Okay, so the precise nature of the human language faculty has been a matter of unresolved controversy for quite some time. And it seems that over the decades that generative grammar has been practiced, we have moved from a more homogeneous theory of grammar in the 60s to a highly disparate collection of mutually incompatible viewpoints as to what a grammar is, or if such a thing even exists. What I intend to do in this presentation is focus on the phonological component and move towards answering the question about phonological UG. I believe that one of the reasons for the increase in entropy in linguistic theory is that we have not paid the necessary deep attention to methodological issues surrounding how scientific theories should be structured. And this leads to disputes over what UG is or what is in UG. So my talk here is ultimately not about what I believe the technical content of phonological UG is. It is basically about the logic that we should apply in answering this question. But of course, I do have a position on that content. And the summary answer to the question, what's in phonological UG, is not much, but definitely not nothing. So the structure of the presentation is as follows then. Well, first, there's some background where I talk about the question of what is UG and the question of what is claimed to be in UG as far as phonology is concerned. There are there are three different trends about the content of UG, and I will discuss those things. Then the next question is what should be in UG, and the answer to that is based on the answer to the question, well, what is a theory? We have to have a meta theory of phonological theorizing, and formal phonology is such a meta theory. I refer you to other works in this general paradigm of research. Then I move on to the concrete proposals, which is to say a minimal theory of representations and a minimal theory of computation. The goal then is to develop an explicit framework for theory comparison. All right, so by way of historical background, the first question is, what is generative grammar and what is universal grammar in generative grammar? As we know, generative grammar in the broad sense is a theory of grammar that was initiated in Chomsky 1951 or before, 51 being the first publication within the paradigm, although it was not called that at the time. The basic characteristics of generative grammar, the classic characteristics are, first, that it's a formal theory of grammar. Secondly, that it describes a mental faculty. Furthermore, that faculty is uniform and language independent, and it specifically pertains to language. And then finally, humans are genetically endowed with that faculty. So given that assumption of what what generative grammar is, then the question is, well, what is universal grammar? I take this quote from Roberts, 2017, to be the best characterization of what UG is. There's also some debate within the generative camp as to how we should characterize UG, but I take it to be the theory of I languages. That is to say, it characterizes the genetically determined aspect of the human capacity for grammatical knowledge. Right? And I'll paraphrase that by saying that UG is the genetically fixed architecture of human language grammar. Every grammar of every human language then complies with or embodies these requirements. That's what UG is and does. Here's an analogy then. System 370 is a kind of computer architecture. It describes a particular brand of computers made by IBM, and that system architecture has certain properties with respect to data and computation on those machines. x87 is a completely different architecture. It describes the Intel computational faculty. That is, it describes what a different genus of computers does. So the human language faculty is analogous to the architecture of some kind of computer system. Well, then what good is universal grammar? That is, what does it do? There are two things that are most important in my opinion. One is that it's the logical basis for learning the grammar of a language from the primary linguistic data. So if you're going to learn a system of grammar from data, you have to know what it means to be a grammar. The second thing is that UG may execute the grammar that is learned. That is, it's not just simply that it tells you what the form of a rule is, but it actually executes these rules. And we'll discuss this point towards the end. So if a child has to learn the form of the palatalization rule in Logori, for example, it has to know that the grammar has rules, and it has to know what it means to be a rule. There is no reasonable account where a Logori speaker or a child attempting to learn Logori is born knowing that their language has this rule. They cannot know that in advance of experience. There's also no reasonable basis for a child to learn that their language uses rules, or it uses constraints, or it uses statistical tables. So you have to know what it means to be a grammar. So then the question is, what is in universal grammar, at least as far as phonology is concerned? There are a lot of specific claims, and there are three general trends that I will focus on here. The first is the classical UG period, that is the SPE era up until about the autosegmental era. The second period is the expansion of universal grammar, basically from 1971 or so thereabouts. So there's an expansion of universal grammar and a contraction of language-specific grammar. And then the current situation that I'm addressing is the contraction of universal grammar and the reduction in general rule apparatus, along with some re-expansion of what's in specific grammars. So this will be the modern era, the golden age. All right, so just by way of a quick overview of what these various theories of phonological UG have been like, we'll start with the SPE style UG. It had basically a theory of rules, a theory of representations, and it had some auxiliary devices. As far as rules are concerned, there's a primary division between elementary rules and rule schemata. So an elementary rule is a rule of this form here where XAY becomes XBY, or the more familiar pattern where X becomes B / specify the environment on the two sides of the dash. So that is what an elementary rule is, and it only refers to feature matrices. But there are also schemata. Schemata are rules which collapse potentially infinite sets of elementary rules. So this might be a rule that says something like plus nasal becomes plus coronal before plus coronal. But very often there are rules that refer to classes of features with different values. So there are other devices allowed that available that allow you to compress individual elementary rules into general schemes. So for example, alpha notation, which I think should be relatively familiar even in these days. There are some expressions for repetition. So C sub 0 means any number of constant from 0 to infinity, plus nasal. Sub 5 would be 5 or more nasals, specifications of things that are nasal. And this expression here, plus voice minus nasal, sub 3, super 4 means between 3 and 4 occurrences of the pattern of a voiced consonant followed by a non-nasal, or sorry, a voiced thing followed by a non-nasal thing. So there are various kinds of repetition operators. And then finally, disjunctions. These are the most popular, that is, you could say something can be either A, B, or C. These are the most popular notations, but there were quite a number of other notations available. Here's an example of a rule in the sound pattern of English. This is the stress assignment rule. As you can see, it's a relatively complicated thing laden with lots of notation here, as well as various statements in plain English, like X contains no internal pluses, or, beta, where's beta? There's beta. Beta is either valued 1 or 2. So rules have this appearance, and this involves lots of rule schemata. What are some consequences of this theory of rules? Well, one of the unfortunate consequences is that the rules about grammar are generally infinite. Because of the property of having infinite schemata. In fact, most rules do tend to include some expression like C sub 0 for any number of consonants. And that expression stands for an infinite class of finite or of elementary rules. This is a bit of a problem, in my opinion, and it's not just me that thinks this. Another property is that schemata are evaluative, which is to say that they reduce the learning cost of the full grammar of elementary rules. So the child is faced with a grammar, they have to learn a grammar that has an infinite set of rules, or at least a very large set of rules. But the advantage of the schemata is that it costs less by stipulation. It costs less to learn these rules. Rules can access many formal devices for compressing simple rules into schemata, such as angle brackets, braces, parentheses, various indices on terms, the bar and box, and double slash dash, and so forth and so on. And as we've seen, they can in fact also include informal English language conditions. So this is a rather, unfortunately, messy theory of rules. The empirical upshot of this theory then is that any mathematically statable mapping seems to be allowed. Notational conventions are posited for some common relations as noticed with, for example, alpha notation and parentheses and so forth. Other relations use quasi-formal or plain English conditions, and the formal theory can in principle access all of mathematics. So for example, in the definition of alpha notation in sound pattern of English, they define that concept in terms of summation. So that means then that summation must be a linguistic concept. As for representations, a representation in SPE theory is an ordered n tuple of segments, and either a segment is a set, an unordered set of feature plus value pairs, or it is an ordered n tuple of values, and features are derivative from a universal numbering scheme. SPE actually uses both techniques. Their technical appendix gives this just a set of numbers or just a set of values theory, but what people actually commonly use were in fact the value plus feature pair approach. There are about 40 phonetically defined features in the theory, and the values can be plus, minus, m, u, and any positive integer. And here's an example of a word, poika, which happens to be the word for boy in Finnish. And that's what the representation of that would, or that's a part of what the representation would look like. I didn't have enough room to include all of the features. Well, so we move on historically. At the end of the SPE era, then there was a deprecation of rule theory and an expansion of universal grammar. So that universal grammar expands in order that you can reduce the things that had to be or could be said in a language-specific rule. So some examples of that pattern or that behavior in linguistics are the crossover constraint and the relevancy condition from the early 70s. The purpose there was to get rid of those expressions that say skip over any number of so-and-sos, and the desideratum was to say, let's just use a variable x and let UG compute what is the content of x. So various proposals were made that allowed you to compute what was in x, which may or may not have worked. In fact, I've argued that they did not work, but that's not really the point here. Another example is the revised alternation condition by Kaparsky, also known as non-derived environment blocking, which prevents a rule from applying to certain classes of inputs, which are computed by scanning the prior derivation, which is something that universal grammar could do. Autosegmental phonology, when it was promulgated, then accelerated this trend of converting explicit rules into UG consequences of what simple rules would do. So for example, the association conventions where all tones link to a vowel and all tones and vowels link one to one, left to right, etc., were part of universal grammar, and they replaced things that might have been in the language-specific grammars of languages. This quote from McCarthy, 1988, sort of typifies the attitude of that era, which is that if you put as much, well, if you get the theory of representations right, then the theory of rules will really pretty much wither up. As if the representations are right, then the rules will follow. That's true if you also have the right theory of UG. Other examples of how UG expanded, the obligatory contour principle, the linking constraint, the onset first principle, and various other principles were added to universal grammar that would say what things could and could not happen in human languages. And then the idea was that this would simplify how you would state language-specific rules. Rule theory could then be simplified with all these additions to universal grammar. One possibility is that we can get rid of rule schemata, and that's probably a good idea to get rid of them because they were not very, they were not well argued. There are two problems with the rule schemata. One of them is that most of the devices, in fact, misidentified the linguistic generalization and they overgenerate in various ways. So the use of braces was in fact most often for putting together consonant and word boundary to encode syllable structure, or C sub 0 was used for ignoring properties that consonants don't even have. Or they were poorly motivated in the first place, so angled brackets or the bar and box notation or double slash dash, which are basically there to get certain technical results in the account of stress in SPE. Rule theory also got complicated by addition of locality stipulations or size of rule stipulations. So not everything was lent to resulted in generating a simpler grammar. Sometimes rules got more complicated, or not rules got complicated, but rule theory got more complicated by adding these conditions to rule theory. Another expansion in this era was the use of parameters. The OCP is a classic example, which says simply adjacent identical elements are prohibited, but then what do you mean by elements? Are all elements treated the same? Are they equally prohibited? Are they equally prohibited in terms of like distance measured in segments versus syllables or stems or words, and so forth and so on. So what happened was that a lot of parameters were added. The OCP then showed up in many parametric versions of phonology. There were also metrical parameters about the size, the construction direction, the sightedness, quantity sensitivity, and so forth and so on for building stress trees. Parameters basically are there to say that there's a small range of specific language-specific choices available, and they're in UG, but we can't say that no language does this or all languages do that. So we have some degree of freedom, and this is how you encode some degree of freedom by putting it in UG. Then the question is, well, what methodological stance unifies the post-SPE approach, and what methodological stance changes moving towards phase 3, the current phase that I'm going to address? Theories were focusing on generalizations about data in language, and the goal in this in the second period was to fit the data, to fit the theory to the data. All right, so the focus is on the data of language and making the theory fit the data. And the argument that I and others have made has that we should, in fact, refocus the attention of phonology to the causal mechanisms that underlie the data. Right, so it's not that we're ignoring the data, but that we're focusing on the causal mechanisms. And this refocusing is still going to be responsible for covering the data, nevertheless. So we're not going to ignore the data, but it's that we have to ask what causes the data to be this way. Some more specific changes in the goals of phonology from SPE to post-SPE period, especially noteworthy, I think, is the shift from devising a theory that is capable of describing any language to devising a theory that's incapable of describing a non-existent language. So this is a kind of strong hyper-Popperianism, which says that a theory must disallow everything except that which you absolutely must allow. What motivated this in phonology or in linguistics in general? I believe that this is actually the consequence of work in syntax from the Peters-Ritchie theorem, which proved that the aspects model of syntax can, quote, do anything. Right. That's a little too distressing, I think, for many people. SPE theory then was considered to be too powerful, and the notation allows you to do all sorts of crazy things that do not exist in human languages. So you could write a rule that says round a vowel which has the same value as nasal as it has for high and the opposite value as it has for back in every syllable that is a multiple of 7, counting from the left of the utterance. And that's a simple rule to write in SPE notation. You just simply have to use the right number of superscripts and subscripts and pair up your alpha values appropriately. So you can write rules that do all sorts of crazy things. We don't seem to need anything that resembles this. This is a problem. So then there was an emerging credo of theory construction, which was that if X can be universally prohibited, it should be. Or to rephrase, a theory should narrowly describe all and only the observed data, including that which we expect to observe in the future. And the best theory is the one that admits the fewest things into the universe. There are other factors that I think played a role in shaping the nature of phonological theory at the time, such as an expansion of the focus of linguistic theory so that grammar is being held responsible for explaining all of a speaker's cognitive capacity regarding language, and therefore we must explain language acquisition, speech errors, aphasia, various psycholinguistic behavioral tests such as WUG tests and artificial grammar experiments. Question is then whether grammars do or should in fact encode all of a person's cognitive capacity with respect to speech. Now moving to the current era, where we have attempted to rebalance the contribution of universal grammar. One of the main contributions in rebalancing this is to refocus on grammatical competence. Hale and Reiss have argued for this persuasively in a number of places, that making the point that phonological theory is about the phonological component. The phonological component maps the output of morphology to the phonetics. Therefore, what happens is the output of the morphology, or the input to the phonology, tawad'u in Arabic, ends up being pronounced, or ends up having the output tad'u. And then that gets pronounced phonetically in some particular fashion by means that are not part of phonology. So this is what phonology is about. This is what phonological UG should be about. It does not encompass the machinery where English jeep shows up as Egyptian Arabic jib. It does not encompass speech errors or performance on perception tests or artificial language experiments. Second point, scientific explanations can be distributed amongst the sciences. Levin, as well as Hale and Reiss, have made this argument. So something that influences the shape of data indirectly influences the rules that are learned based on that data. So a lot of regularities in language are simply the result of historical change. The nature of the grammar then is a consequence of the historical changes, which are a consequence of various functional factors that shape the data. But not every regularity is encoded in the grammar. So physics can affect waveform properties, and that affects perception, and that affects the data, and that affects the child that uses this data to construct a grammar. But physics is not part of the grammar. Another contribution is reappreciating the role of Occam's razor, or as Chomsky has raised the question more recently, how little can be attributed to UG while still accounting for the variety of I languages attained. I give you here a set of 3 classical and 1 not classical statement of what Occam's razor says. I'll take my favorite, which is the Aristotelian statement, which admittedly is hard to understand because he writes in ancient Greek. We may assume the superiority, ceteris paribus, of the demonstration which derives from fewer postulates or hypotheses. That is, don't bloat theories with machinery, which yields a close matching of theory to data. That is, you want simply a theory which is as simple as you can make it be. So then we need an epistemological framework for phonological theorizing, which I'll just refer to as formal phonology. The question is then, how do we approach, how should we approach answering the question, what is in universal grammar? Well, to do that, we need to have a theory of knowledge. So we have to have an epistemology. What is a theory? Well, theories are deliberately created and they serve a particular purpose. They serve the requirements of human knowledge. So what does that give you? Well, we need our knowledge to be compact but open-ended. So it has to encapsulate knowledge of past and future observations and states, and it has to do so compactly. So the requirements of theory are determined by the purpose of theory, which is representing knowledge. A theory, all right, now here's then a sort of one of those essential definitional things I will give you. A theory of a thing is a system of well-established simple propositions that state the essential properties of the thing. The thing that defines the subject matter of phonology is the phonological component. So the fundamental question of phonology is, what are the essential properties of the phonological component? What are essential properties? Now, not everything that is true is an essential property of the thing. So it's a true property that a phonological rule may change over time, but this is an extraneous proposition about phonology. It's a theorem from other propositions, most of which are not even in phonological theory. So it's not an essential property. A property is non-essential if its truth follows from the truth of other propositions. All right, so that's what we mean by a non-essential property, and therefore things that do not follow from other things, those are the essential properties. A theory is a system, not a bag of claims. All right, so what does that mean? Well, propositions and concepts are connected in a hierarchy. An example is biological taxa, which is the quintessential scientific hierarchy. Here we have a number of observations. There's a husky, there's another husky, there's a Samoyed, there's a Malamute, and there are a bunch of other dogs here. And we group them together into these general concepts like husky, but we also group all of these individual kinds of dogs into another node in our biological taxa, Canis lupus, and so forth and so on. And then we go on up the tree to the various other levels of organization in biology. These are all evolutionary claims. These are all claims about what has happened in evolution, and there's a hierarchy to this stuff. All right. What the notion of a hierarchy does that's most important, I believe, in phonology is that we can inherit conceptual properties from the theoretical hierarchy. So let me give you an example of the inheritance of conceptual properties. Well, I could say that a triangle is a connected series of 3 line segments on a plane where the first vertex coincides with the last one, has no holes and does not intersect itself. And then I can make a similar statement about squares, and these are not good theories. And why are they not good theories? Because they're very redundant. All right. Instead, what I should say is I should say that a polygon is a connected finite series, et cetera, et cetera, et cetera. And then a triangle is a polygon with 3 line segments. So note what I've done here is the properties of polygon are inherited by triangle. Also, the properties of square, the properties of polygon are inherited by square because it depends on understanding what a polygon is. So that's the sense in which concepts can be inherited from a superordinate concept. So what do I mean by a well-established simple proposition? Okay, so scientific propositions are not to be arbitrarily stipulated and accepted. Evidence is outside of the theory, but yet evidence is what justifies a theory. So there must be evidence for a theory. On what basis do we say that a theory is justified? Well, the most important one is truth. We'll say that a proposition is true if it correctly describes a fact. So here we have the classic Aristotelian state, the correspondence theory of truth, to say of what is that it is not, etc. This is a really hard sentence to try to understand. Anyway, a proposition is true if it correctly describes a fact. What are the reasons that we have to believe that the proposition states what is? Well, the first thing is that we must evaluate alternatives. That is, we don't just simply say that, yes, the statement is true, but rather we have to consider the alternatives that there are in order to evaluate that this proposition states what is. So there must be some awareness of reasonable alternatives and a comparison of how strongly those alternatives can be ruled out. So now this then raises the question, well, how does constrainedness work in this epistemology? Constrainedness and its relation to theory evaluation is actually important, although I generally avoid the consideration of constrainedness that says, we've discovered that this theory allows an unattested language, it therefore must be wrong. An unconstrained proposition that anything is possible describes what is, but it also says what is not, says of something that is not, that it actually is, and that's false. So there is actually a reason based in the concept of truth that says that an unconstrained proposition is not a good thing. It's not a good theory. So the question that has to be asked is whether there is an alternative proposition that better identifies what is. So it's not that the particular proposition is unconstrained, but that there is a better alternative. Then the third question is, which theory is simpler? All right, so we have a set of theories. We have not just one theory, but we have multiple theories. Which one do we select? We should select the simplest theory. But how do you determine simplicity? It's very simple. You count. What do you count? You count everything that's in the theory. Well, to do that, that means that theory has to be formalized. So then you inspect the concepts and the proposition that define the theory. And then you ask, which of these theories has the fewest things? So now I want to move towards a specific minimalist theory of phonology. First question is, where is phonology in the hierarchy of the theory of mind? You have to have a theory of mind in order to have a theory of phonology. So here's my theory of mind. I put this together. It's not the classic 49 circles inside the head picture that you see. So the mind has various faculties. I'd say, yeah, we have a faculty of perception, we have a faculty of memory and focus and reasoning. That's where I'm going to focus my attention, because I believe that language is an aspect of the faculty of reason, as is logic and conceptualization. Phonology then is one of the components of the faculty of language. So is syntax and phonetics. So that situates where phonology is in the theory of mind. It's part of the theory of language, is part of the theory of reason, which is part of the theory of mind. So what then do we need to say in phonology? Now, if you look at some basic phonological concepts, we have representations and rules, or however you want to, there might be constraints, but some kind of computational device. We have features, we have underlying forms, we have surface forms, we have segments and words. How much of this is in universal grammar? Okay, well, let's first remember that we have the concept of conceptual inheritance. Propositions that are true of superordinate things may be true of the subordinates. So for example, mammals are warm-blooded, and therefore we do not say that humans are warm-blooded. So a theory of humans would not say humans are warm-blooded, it would say humans are mammals. And the fact of being warm-blooded is inherited from the fact of being a mammal. Some concepts that are used in phonology are in fact broader linguistic or even cognitive concepts, and they're not part of phonological universal grammar. Essentiality then rules out concepts like spread. Spread is not essentially different from insert, and underlying form is not an essential concept of phonological theory. So spread is just the insertion of an association relationship or a dominance relationship, and an underlying form, although we talk about them and we say, yes, we start with the underlying form, no part of the theory actually cares about the underlying form, unless you've got a theory that refers directly to underlying forms, but I don't have such a theory. So there are some theories that do in fact refer to the initial state of the phonology. So it's not that it's logically not part of phonology, but I argue it's empirically not necessary as part of the phonology. Representation isn't a quirky thing about phonology, it's a fundamental construct of the theory of mind. The mind is full of representations, and therefore phonology freely uses the concept of representation. What phonology does is it adds some phonology-specific propositions that are true of phonological representations. So it's not everything about representation, but there is phonological stuff about representation that has to be said in UG. So how much of the theory of phonology is specifically phonology or phonological? What is the minimum additional content to the theory of mind specific to phonology that's required to have a viable theory of phonology? All right, so we're getting to the answer now. The logically fundamental objects of phonology, the higher level concepts that are that potentially have phonology-specific content are representation and computation. What is a representation? Well, it's a set of node types and relations between nodes. So what is the least that we can get away with in a theory of representation? Well, one, we have the concept of a node. This generalizes over feature, organizing node, and supersegmental. Now, node is actually not a specifically phonological concept. In fact, syntax is full of nodes. There are types. That is then a property of nodes. So some nodes are of the type voiced, some nodes are of the type place, and so forth and so on. And then finally, there are two node relations, a relation of dominance and the relation of precedence that exists between nodes. So we can say that X dominates Y, or X precedes Y, and those are also relations. But these are all zero-cost things to phonology. They are inherited from the higher theory of human language, or even cognition, because any conceptual hierarchy is a set of dominance relations between nodes of particular types. Syntax is full of nodes. Some nodes in syntax dominate other nodes in syntax. Nodes may have features. I mean, I'm not clear on what goes on in syntax, but I believe that nodes have types, namely features, and some nodes precede other nodes because there is word and morpheme order, and there may be some sub-theories of syntax that are less interested in word order, but nevertheless, nodes are in fact ordered before you get to the phonology. But is there anything phonologically specific to phonological representation? I haven't yet given you anything that's phonology in the theory of representations. Yes, here there are some things. One thing is that precedence is defined only on nodes of the same type. That's a claim. Secondly, and this is not entirely self-evident, dominance is only defined on nodes of different types. All right, so those are the two claims about representations that I claim are part of phonological UG. So here's an example of a representation that's allowed in the theory. It's a standard representation of something like bat. All right, and this is the graphic version of what the thing, what it would look like. This is what it in fact logically is. Underlyingly, it's a set of dominance and precedence relationships between the various nodes, such as the first syllable node and the first root node, or the syllable node and the third root node, and so forth and so on. And so that is in fact what a representation is, logically speaking. There are some additional propositions that might be entertained. These are in fact these are assumptions that are made in unified features theory. One of them is that there's a specific list of types. So voice, nasal, coronal, and so forth are part of the UG inventory. Also, types might be more complex, so they might be more than just labels. They might be pairs of labels and values of various sorts. And there might also be, in fact, universally mandatory dominance relations, like place dominates coronal or laryngeal dominates voice. These are all properties of UFT. Then if I want to compare the theory that I've set forth, which is radical substance-free phonology versus the privative theory of unified features theory, I would then simply say, well, what are the propositions that characterize UFT? One of them is just simply this here. It's a list of the specified node types. That's a property of UG in that theory. Also, these admissibility propositions that laryngeal dominates voice and not something else. What is the simplicity of the two theories? Well, it's actually fairly straightforward that UFT and RSFP are the same, except that UFT adds some things. So that is exactly the extent to which UFT is more complex than RSFP. So that's the additional complexity of that theory. And that's what I mean by count. Now, I want to defend, or try to defend UFT because although I think, the defense won't go through, but it's important to see what in fact might be an argument against the theory that I've given. I won't pursue this too much because I hope maybe Charles will pursue this some, but the question is, how do you explain the lack of a rule partially assimilating place and voicing only? As given this representation here, this is a possible representation in RSFP where place dominates not only your classic place features, but also the feature voice. And then couldn't you therefore have an assimilation that it assimilates just the place features and voicing? And that's something that UFT does not allow. We don't find a language that works like that. So how do I explain the lack of such a language? Well, the answer is, first thing is that it's causally improbable. So I appeal to third factors, namely the historical and phonetic precursors to place assimilation are different in these two sorts of scenarios where you get place assimilation and voicing assimilation. Now, just because you can imagine there being such a rule in a grammar does not mean that there is a likely historical path that could give you that rule. But the other thing is that if you ever find that it's necessary to encode a restriction in the grammar of a particular language that says, do not put place under so-and-so, you can still do that. You can always add something into the language specific content of a grammar that says, do not place voicing underneath the place node in this particular language. So the general conclusion then is that the theory of grammar should not be held responsible for tightly fitting universal grammar to the nature of the observed data. What is the computational payoff for universally prohibiting an imaginable structure such as that previous one with voice under the place node? Is there a computational payoff? Well, that then brings our attention to the problem of computation, the third rail. What is a computation? I will assume that computations proceed with learned ordered rules. So a grammatical component X is a collection of rules that enters into precedence relations. Now, is this part of phonological UG? Traditionally, this would have been a characteristic of grammar, not phonology. However, syntax has, I'm not clear on whether I don't think there are rules in syntax anymore. I don't understand how syntax works. So I'm just going to say that apparently rule is something that only exists in phonology, apparently. So I'm going to shoulder the burden and say maybe this is in fact a special characteristic of phonological computation. The fundamental question then is, for me, what is a rule? So a rule is a structured representation. It's just another representation. It has three sub-representations. First, it has a structural description. Second, it has a structural change. And third, it has an operation. The structural description and structural change are familiar kinds of representations. So an example of a rule is spread place to a nasal, which is immediately to the left of something. And the way you would write this or formalize this would be to say that when you have a dominance relation between a nasal on one root node and place on another root node, and the first one precedes the second one, well, that's what you're looking for. That's the structural description. The change is that a dominance relationship between the first root node and the later place node is what comes into existence, and the operation is insert. All right, so what you do is you insert that thing. So we can reduce a rule to a triplet of two conventional kinds of representations and one thing, the operation. So an operation is in fact a sort of a special thing that's peculiar to rules. There are two subtypes in this theory, namely insert and delete, and this is fixed in universal grammar. This does somewhat blur the distinction between data and computation, but that's not a bad thing. I mean, when you compute compute on any general purpose computer, as far as I know, computation simply is the action to be performed as specified in a particular form of datum, which is acted on as an instruction. So there's some other questions about rules, namely, are there universal grammar restrictions on what can be in the structural description or the structural change? For example, you could add to the theory a condition that says the structural condition contains at most 2 segments. That actually was a proposal in the autosegmental era. We may add the proposal that the structural change contains 1 proposition and no more than 1. How do we compare pre-optimality autosegmental phonology with this theory that I'm talking about? Well, the classical theory basically adopted the above theory, although the names were different. So we talked in terms of targets and triggers, spreading and delinking, but those are just simply ways of talking about classes of representations and the structural description aspect versus the rest of the structural, well, the focus aspect versus the rest of the structural description and the operation. Then in addition, the autosegmental theory added various conditions to the theory of rules, such as the OCP or the linking constraint, which would say things like the output of a rule cannot contain adjacent identical nodes. The present formal phonology theory attributes less to UG than does classical autosegmental phonology. So it essentially, it takes a certain core from autosegmental phonology and then throws away a lot of the stuff that was in universal grammar. What's the downside of saying, what's the explanatory downside of saying less in your theory of computation? Why not say more in the theory of computation? Well, the problem is then that we allow a description of states that have never been observed. So we overgenerate if we don't include a lot of conditions on universal grammar. But so what? What's the problem with that? The question that we should ask then, is the non-observation because of the nature of phonological computation or because of a third factor? That is, functional explanations which shape the data. So if it's because of a third factor, then we don't worry about it. On the other hand, if it is because of the nature of the phonological computation, then we might want to consider that there is a problem that needs to be addressed. So there can be cases of overgeneration on a large scale, and those are in fact relevant to theory formation because they will suggest possibly we have misidentified a causal relationship. So a classic example is the use of alpha notation in SPE phonology. The main problem is simply that it made the wrong generalization, that it said that in fact we have a concept of generalized variable when in fact the underlying concepts were much more restricted. They were simply becomes the same as, and that's not the same thing as saying, yeah, whatever, move on. All right, so then finally, I want to move on to the engine here. I've made some allusion to the engine. Here's a standard autosegmental format rule. And here's the rule in proposition representation format. So these are basically the same thing. So a rule is the thing that exists in the language of a grammar. It says what language specific things exist that are the computation. But the problem is that a rule is not self-executing. It doesn't say how the mind relates the structural description elements of the rule to the properties of a string in order to decide that the rule applies to to decide whether apply the rule to a particular segment in a string. The rule does not actually contain a mental action, and yet what happens when a rule applies is that there's a mental action. A rule doesn't contain a mental action. A rule does not specify how to access memory locations, and a rule doesn't specify patterns of neuron activation. A rule is, in fact, a representation of a potential action, and the engine performs the action. The engine, I claim, is then part of UG. It is a cross-linguistically invariant thing, and that too is then part of UG. So then saying what it is that the engine does is an important part of UG. All right, to summarize then, sound scientific theories require an epistemological framework. Knowledge is organized hierarchically and is built up starting at the bottom. Simplicity is fundamental to human cognition. Hierarchy is essential to achieving simplicity. The concern with overgeneration in linguistics, I believe, is misguided, but the concern with correct conceptual identification is appropriate. And that's what I have to say about this topic.
Seung-Hwa, am I supposed to start talking now?
Go for it.
Okay, or maybe we want Seung-Hwa to. Okay.
No, yeah, I think you can moderate now.
Okay,
Discussion.
I'm going to moderate as well as I can. I'm not a very moderate person. So thank you, Dave. That was fantastic overview, and many things that you said are things that I've learned from you over the years through your papers and through our conversations. And sometimes I realize that we're actually trying to make the same point, but we've just got a different vocabulary. And so can I just ask you to I'm going to throw out two terms and see if you can maybe restate some of what you just said. This issue about having the fewest things in your universe, right? Defining your the fewest things in your universe. So I think constraints, dealing in constraints sometimes screws that up, right? And the terms that I'm interested in are defining things intentionally versus extensionally. So when you say having the fewest things in your universe, you mean in your intentional description of UG, the primitives of the theory.
No, the extension of the theory should be small. So like the number of particles in the universe ought to be a relatively small number, and a better theory is one that says that there are fewer particles than more particles.
But what if I say, what if my theory has features F, G, and H, and they're freely combinable to make segments, and plus and minus F, G, and H, and so I get a bunch of segments, and then I add a constraint that says star plus F plus G, which rules out a certain class of segments. So now I've intentionally, my intentional characterization of UG has gotten bigger by virtue of adding this constraint, but the number of possible segments has gotten smaller. So is it obvious which way you want to go with that, or is this an argument against constraints, or is it do you really want to say that it's about the cardinality of the extension of languages?
No, I have absolutely no interest in the cardinality of the extension.
Okay, but I thought you said it's the so when you say you want,
I don't care how many. I don't care how many features there are in the universe. I don't care how many particles there are in the universe. What I care about is how many principles there are in the theory.
So I think then you're saying the intentional characterization of the characterization of the theory gives you certain principles and primitives, and then that model of UG extensionally describes a set of computationally possible languages, right?
Yeah, sure. I mean,
So you don't really care about how big that extension is. You want to make sure the intention is small.
Yes.
Absolutely. So you won't posit a constraint star plus F plus G. You'll look for another solution, maybe.
Well, no, I'm not looking for a solution.
I mean,
I haven't been given a problem, right?
You'll judge better the model of UG that doesn't add that constraint in.
Yes.
Yeah.
Yes,
Okay.
that's
All
correct.
right. So yeah. Okay. So because I find that this, this intentional, extensional, they kind of go in opposite directions, right? That it can be very confusing, right? What are we describing things intentionally or extensionally? And so I think we agree in the end on that, which is
Yes, I'm pretty sure we do.
okay. Great. Let me pick on some very tiny thing. I think on slide 28, you said that a phonological rule can change over time. Could you tell me what you meant by that?
I would love to. Wonder why I can't. There it is. 20. Well, anyway, yeah, I'll just tell you what I mean by saying a phonological rule can change over time. Yeah, okay, I see. That's a sloppy way of talking about it, I suppose. I can only think in terms of the languages that I'm working on. So there was a rule in the grammar of Liguori, spoken, maybe 100 or 200 years ago or whatever, and it used to have a particular form. And over the last 100 years, that rule has changed its form. It's not that it's sort of non-existent anymore, but it's that it simply has changed because the facts have changed.
So you're really saying, so Liguori is not really a thing. There's just a bunch of I languages, as you said. And we kind of informally, we say it's the same rule. But
yeah, right. Yeah. So I'll give you,
you're talking like a human, not like a linguist in that sentence.
Right.
Basically. Okay.
Exactly.
Yeah, that's, I know that. I just wanted to clarify for some members of the audience.
Thank you for forcing me to clarify that point.
Okay. Did you want to say something else or should I keep going?
No, go for it.
I'm just going to check the comments and see if anyone's posted anything yet. Okay. There's one, I'll get to it. You talked about the logical basis of the model and the things that are in there. And I think that you're saying that there's no language specific features, that the features are given universally. Is that true?
Well,
or is that what the claim is for now?
Okay, no, remember, I'm talking about phonology in general. So if you mean my theory versus your theory versus SPE theory versus other theories. So yeah, there are theories that say that the content of the set of features are given in universal grammar. My position is that what is given in universal grammar is the concept of node and type, but the specific types are not given in universal grammar, that they are learned. But what is learned is sort of the basic syntactic structure of node and type. So it depends on whether you're talking about my theory versus somebody else's theory.
Okay. All right. Just to not, since we've talked about this before, and not to take up too much time, I'll just refer people. There's this discussion in this Chomsky and Hale 1965 paper, a reply to Householder, the structuralists, about I'm not trying to make an argument from authority. It's just that sometimes you come across anything you try to say, you find out that Chomsky and Hale said it already, or it's often the case. So there is a discussion about why there are reasoning behind why you wouldn't want to have features on a language specific basis, why you need to have universal feature set. So that's just in the Chomsky and Hale 65 paper. So something we could all look back at and think about. Okay. Something else that actually I don't know how to fit it in exactly to what you said, but I think you'll see the point. I think somebody told me that this comes from Richie Kane. So I've been maybe you've seen me make these combinatoric arguments, with 4 features and under specification, you can describe 10 to the 24th languages, segment inventories, if you do your simple combinatorics. So, and I think there was something in your talk that also involved, possible combinations of things. And so what Richie Kane says is, given the combinatorics, the probability of any particular language is vanishingly small, right? You're heading towards infinity, and you get, it's 1 out of an infinite number. So when there's a gap of a certain type, it's almost, it's kind of meaningless, because the probability of any particular pattern is basically 0, right? The probability of any particular pattern is infinitesimal. Do you buy that? I mean, there's the diachronic filter and the phonetic reasons why some things are more likely, but I think it conforms to your claim that we shouldn't worry about our model overgenerating.
Well, okay, so I'll give you an example of a robust overgeneration, and my explanation for it. I originally, in 1985, in fact, believed that there was an empirically valid generalization that no human language has both pharyngeals and clicks. It turns out that Dahalo has pharyngeals and clicks. So I've retreated on that generalization and said no human language has pharyngeals, clicks, and implosives. And as far as I know, this is an unfalsified claim. What is the explanation for this? The explanation for this is basic multiplying of probabilities, that the probability of having pharyngeals and clicks is, the chances of having pharyngeals is low, the chances of having clicks is low, the chance of having implosives is low, multiply all those things, and the chances are effectively 0. All right, so that's the kind of reasoning that I use. On the other hand, well, I guess I don't want to name the poison that would make me succumb or something. But why? Yeah. If, for example, no phonological rule operated from left to right, that would be really distressing, because that's not a gap. That's not a small gap. That's a gap that will instantiate itself, or theoretically would instantiate itself, if we see rules as being sort of randomly distributed. That's really funny that in a very large number of rules, in fact, we find 0 examples of that. So the probability of any particular language, in fact, namely a language that has a rule that applies from left to right, is not infinitesimal. It's actually extremely high. And if that were a real gap, then I think we would have a problem that we would have to explain. So I would say that, no, it's not the case that the probability of any one language is low, except if you mean any one language, like, well, you can never find a language that's English, but that has front round vowels instead of ooh.
Yeah, right. Yeah, I guess it's explicit enough. All right, so let me ask you something completely different from a member of our audience. So Gladys Massini Cagliari wants to know if the idea of UG can have any relation to AI technology applications. It's not your.
Yes. Okay, like in my dreams, yes. So what I would like to know is, I would like to know how human language can be acquired. So is there some AI type application that would allow one to perform the reasoning that's involved in acquiring a human language? And so a large part of that really is about the reasoning, the reasoning aspect. The question is whether or not the model of grammar and rules that I've proposed could then be plugged into a model of general reasoning, and where you could actually say, aha, the child will learn this language given such and such data, and do a computer simulation. I'm not going to do that. I can't do that, but I think actually in principle it is doable, and it would be very interesting to me to see this done if it's based on reasoning.
I think one place that people don't often think about, because of the relative status, I would say, of linguistics and AI research, is that I've learned a little bit about this talking to John Rowski, is that the AI people and people working in neural networks and all have been admitting more and more that they need to build primes, they need to build primitives into their systems. They basically need to give their machines an initial state, a UG, initial biases. And so so in some sense, the technology people are learning from the linguists that they've got to start. They can't just have an all-purpose learner. And so in that sense, there's some connections. We can tell them how to make better AI if they would only listen to us.
Yeah.
I don't see anything else from the audience. So Sunghua, when should we, how long should we go? We have some more time still?
Yeah, we have a few minutes more. If you want to go, yeah.
Oh, let's see. Dave, should I try to get your ire up?
Go for it. Do your best.
It's not going to be, I'm not the target. I'm not, okay. It's okay. So lots of people have been doing artificial grammar learning experiments to try to give us insight into how phonology is learned and the nature of human phonology. Do you have any opinions on this kind of widespread research program of artificial grammar learning?
I do indeed, but I'm not sure that I'm going to give them in an unfiltered form.
Okay.
Let me say that I find that they are a bit problematic from a methodological perspective. I've never witnessed. I've witnessed talks on the topic, but I've never actually witnessed the test being administered. So the thing that kind of puzzles me is, how do you set it up? How can you set things up such that in 45 minutes, maybe an hour, if you really abuse the students, but we're talking about undergraduate students in, taking a psych class or a linguistics class, and they're experimental subjects, and they sit there for 45 minutes or so, and they perform in some particular fashion. And how in the world do they learn it? Well, I've worked on enough languages to know that you cannot induce the grammar of a language in 45 minutes. So they can't induce the grammar of a language. I think anything else that I could say about the paradigm would be sort of ad hominem, and there's no homin that I want to, that I would want to attack in this particular domain. But I think that approach is highly problematic from a cognitive point of view.
Okay, let's see. Here somebody's asking, Arawan is asking for your thoughts on the use of neuroevidence for identifying what's truly phonological, like, velar softening. Is it, you can see what the brain's doing and try to decide. Do you have anything to say about that?
I do. I would like to actually have someone perform these experiments on uncontroversial cases. I would never start with velar softening. Instead, what I would do is all right. So Logori is my current main obsession. I would start with Logori speakers, and I would stick them in the brain machines, and I would determine what they do. I would try to detect the presence of uncontroversial phonological rules. And also, I would try to distinguish uncontroversial phonological rules from things that happen that aren't clearly phonology. And once we have the technology that allows us to distinguish phonological rules from, for example, lexical entries in an uncontroversial case, then we can also look at questions like, how does velar softening work in English? I know exactly why this is not going to happen, because the number of Logori speakers who are available in labs is really small.
Okay, let's go. So Alex Chabot says that Lakatos and some linguists have said that the use of a theory is to make predictions about what can be. So this is the other side of the Popperian coin. In a theory that freely overgenerates, what kind of predictions can be made? So Alex is saying I think he's saying that you're advocating a theory that freely overgenerates. Is that fair?
No, no. I advocate a theory that accidentally overgenerates. So it doesn't freely overgenerate. That is, the theory it does exactly what. So the individual components of the theory are all individual. They're all each well motivated on their own right, but there can be some interaction between aspects of the theory where in fact we don't have an attestation of that thing. So for example, the theory of feature representations really ought to allow there to be a language with clicks, implosives, and pharyngals, and yet for some reason there aren't any. And so I don't freely overgenerate, but I do overgenerate in that type of area. I hope that covers the base.
All right. Oops, there's nothing else there, but I have one or two more. So Seung-Hwa, just cut me off when we need to stop, okay? Oh wait, yeah. Okay, how about, so when you're just talking about what's particular to phonology, and you say, well, nodes are not particular and precedence is not particular and all that. I mean, if you look inside a computer and it's processing a video file or a text file or a sound file, from the computer's perspective, or just looking at what's going on inside, you can't tell the difference, right? It's all zeros and ones or whatever. It's all, it's all electromagnetic states, right? And so at some level, if you go deep enough, everything that's phonological is going to look like everything that has to do with, running, right? And so is there any, I mean, I think you tried to address some of these things by talking about types and the features and so on, but, is hierarchy or dominance, is phonological dominance really the same as dominance in other domains? Is it, memories are structured, phonology representations are structured, syntactic representations are structured. So how do we know when we're going too far down, when we're trying to figure out what's phonology?
Well, all right, so, okay, I'm going to object to the use of the word really, because yes, either it is the same or it isn't the same. So if it isn't the same, then there's going to have to be some important difference. Now I've tried to take pains to make it clear that not every fact about dominance relations in phonology is the same thing as in syntax or as in any other mental domain. But what I am claiming is that in fact, dominance is essentially the same thing as conceptualization. That is, there's a relationship between a concept and the things that it refers to. So I take that to actually sort of be the fundamental highest level unifying thing. The thing that there's a general property, and then the things that specify what that general property are. So I think that there is a level of abstractness in which they are exactly the same thing. Now, I don't know. I mean, I don't know how to be more. I can just simply say, yeah, maybe there's some implementational difference, but I don't yet see the evidence that there is a real difference between dominance in phonology and other similar looking notions in cognitive science in general.
But should we even worry? I mean, so, you make an account of some phonological phenomenon and you use precedence and dominance and whatever, and we feel like, oh, that gives me some insight I didn't have before. Why should we really, do we need to worry about, is this the same dominance that's in this other domain? I mean, if it's helping.
I mean, when we get to the point of talking about the low-level wiring, yes, I think it's an important question. But we're not at the point of talking about low-level wiring. So nobody has yet come up with a proposal that says, well, here's a wiring difference between this and that. Okay, let me put it this way. The wiring that's involved in the System 370 computers is radically different, and yet they are all logically the same. So there are different models of 370s, a lot of different models of 370s. But the logic of what they do is the same. And it's an interesting question then, so does the human mind have different wiring methods? And how do these different wiring methods come about? But the underlying goal, that is what you're wiring for, is in fact the same thing, as far as I can see.
Okay, I have one more. I guess we'll aim to stop at half past whatever the hour is by you. Okay, so let's see. So I know I was recently reading a bunch of grant proposals from linguistics, but in various domains. And a bunch of them make the argument that a problem in the field is that people don't use naturalistic data. They're like, well, how can we judge, how can we figure out what's going on in real language if we don't use real data? How people use language really out in the wild. And all this stuff done in labs is it's not real. Do you have anything to say about that? About, so people want to harvest data from YouTube videos, whether it's people speaking or people signing or something like that. And I think that's, I think there's a lot of people out there, psychologists and some linguists, who think, yeah, that's really important because we got to get the real data, not these artificial situations where people are producing forms. I know you obviously do lots of field work, and I don't. So you should have a lot to say about something like this.
Yeah, I do. So it sort of depends on what your goal is. If your goal is to gain a deeper understanding of what is going on in a particular language, what is the grammar of this language, then I'm very skeptical about being able to use so-called naturalistic data. So the thing is that in a language that's got a particularly robust morphology, you're not going to encounter the kinds of combinations. So you're not going to encounter the perfective, completive, focused class one subject prefix with vowel initial verb, et cetera, in the bare future that's necessary to establish such and such a rule. And so there are these grammatical analysis facts which crucially depend on being able to get particular kinds of forms, and they may not be the most common things in the world. And yet children learn this stuff, and speakers of languages learn these things. And where do they learn them from? Well, they learn from observation. We linguists are not good enough to be able to figure out how to harvest this stuff from so-called naturalistic data. As for YouTube, however, I do have a particularly strong view that one should not use anonymous, unsourced data on human languages unless you know that the participants speak the language. So, I would never use myself as an informant of Logori, and yet I can make myself be an informant of Logori by blogging in Logori, and it goes out there on the internet, and it therefore gets harvested and becomes part of the corpus of Logori linguistics. The only problem is that it's made by a guy who doesn't speak the language. And I think that's a real problem. So I think that the use of unfiltered internet data is a very bad practice. And there has to be some sort of control on what is the actual source of the data. But, you know, yeah, that's my opinion on that.
All right, we still have 5 minutes. So Alex Chabot wanted, I guess, a clarification. You admit or you expect there to be accidental gaps, and then there's going to be systematic gaps. How do you distinguish between the accidental and the systematic gaps?
Well, okay, so there can be systematic gaps that are explained by numbers of reasons. So one of them, for example, hypothetically speaking, length harmony. Imagine, you know, there might be hypothetically a rule of length harmony, but yet nobody has detected an example of length harmony. So the question is, you know, is that a real gap, or is that just an accidental gap? And I would say that it's a real gap in at least a certain fundamental sense, that it is a gap that has a functional explanation, not a formal explanation, but a functional explanation, right? And so to the extent that that functional explanation is a strong one, then there won't be any such thing. So I would say that I would not dismiss that gap, but but at the same time, I would not say it therefore entails a change in the formal grammar. On the other hand, and the reason why I think that it's systematic is that a little bit of combinatorics on how many languages have harmony and how many languages have vowel length yields the result that I did not compute, but I, you know, at least thought about, well, how would I figure this out? There are so many thousands of languages with harmony and so many thousands of languages with vowel length that surely there must be some language that has vowel length harmony, and yet there isn't one. So I think that's statistically significant.
I mean, would you endorse the idea that that's what a theory does for you? It tells you what's accidental and what's systematic, which gaps are accidental and which are systematic, and you know, this is a good theory. And
I mean, so either I could have a theory that says, I could have a phonological or a grammatical theory that says we cannot have such a thing for such and such reason, and that would tell us that. Or I could have a functional theory that would tell us the same thing. So it doesn't actually tell you which explanation is right, but we actually won't know without there being some theory that some gap is, quote, systematic. So everything should be an unsystematic gap until you suddenly realize, oh, maybe we need to have something in the theory. So I think that discovering that it actually is systematic in the sense that it's statistically predicted and yet not found, that's the information that we need to go fix some theory. And then the question is, which theory do we fix?
I think somewhere Chomsky said that when you have grammaticality judgments that you're not sure of,
right,
let the theory tell you, right? And then you know the theory may be wrong ultimately, but for now I predict, you know, I can't tell if this is grammatical or not. It's, you know, it's too hard to process. And so I just say, well, what does my theory tell me? And then I keep going, I keep working, and if that prediction seems to be useful and lead me to interesting things, I say, okay, the theory told me it was ungrammatical, and I think that was the right decision. But we don't have access to the ultimate truth, right?
Right. No, I accept that.
Okay, Seonghwa, should we wrap it up?
Okay. Thank you again for your great talk, Professor David Odden. And thank you very much, Professor
Thank you for inviting me.
Great discussion. Would you like to say a few words before we end transmission?
I want to thank Abralin for the opportunity to make this presentation. Thank you for the invitation.
Thank you.
Thank you.
Okay.
And thanks to Charles.
Thank you all for joining Abralin ao vivo, and I hope to see you again at the next Abralin ao vivo.
All right.
Thank you very much.
Good night, everyone. Goodbye, everyone.
Bye-bye. Thank you.